Hi guys, and today we're going to do some revision for the Edexcel GCSE PE paper 1, and we're going to focus on the biomechanics areas. This typically is an area where students get a bit worried about. It can be confusing, but it is a very regular question that comes up. So I'm going to try and break it down for you to make it a little bit easier for you and hopefully help your revision ready for the exams. We're going to break it down into planes and axes. So if you're making notes, you want to break it into these 4 areas. What planes and axes are, what the concept of a lever system is, because that can be a question on its own. And then we're going to look at the mechanical advantage and disadvantage. I've highlighted advantage because that's more commonly asked. And then we're going to look at the different classes of levers. So starting with planes and axes, and we've got a lot of information on the screen. So let me explain it to you, and hopefully it will make life easier. So a plane is the direction of movement, whereas an axis is what rotation, where the rotation is going, in which direction the rotation is happening, or which point the rotation is taking place in. So a plane is which way they're going. Okay, and then axis is if they're rotating, are they going forwards and rotating forwards and backwards, or are they spinning side to side, for example? Now, way to remember it is FST, and let's use it as the direction. Okay, so F is forwards and backwards. So F is the forwards and backwards, S is sideways movements, and T is twisting movements. So if you can remember those 3 terms, FST, and that gives you your direction, okay? So whichever, and we're just talking about the movements. So is it a forward and backward movement? So an example that the example do love to use is somersaults. Okay, they love the somersaults. I've just taken a few clips of that, and that's a forwards movement, or it could be a backwards movement, and they'll dictate if it's a piked front somersault or a tucked front somersault or a back somersault. But if it's got the word somersault in, we're talking about forwards and backwards movement, F. They love to use cartwheels, which is a sideways movement, S, and they love to use, they put a full twist, and just behind my image there, there's a picture of someone doing a full twist, and the T for twisting. Okay, so we've got F, S, T. So straight away when you get these questions, figure out what are they doing. Are they going forwards and backwards, side to side, or twisting? So once you've written, and then write down F, S, or T, okay, so you know. Then start with your axes. Okay, the axis where the rotation is taking place. And if you've written F, we've got frontal axes. Okay, and then if you've got S, you've got sagittal axes. So it's generally one of these 2 areas. And if you remember the F for forward movement and think, right, which axis is it happening? So we've got our frontal axes and the plane, the direction of movement. So frontal and sagittal always go together, no matter what way around it is. So they change throughout the orders, but if it's a frontal axis, which means the point of rotation is at the hips, so up there on our performer, they are moving in a sagittal plane, which means they're going forwards and backwards. If it is a sideways movement, it is a sagittal axis, so the point of rotation is in the belly button there, and they are moving side to side down sideways. If you imagine going down a corridor sideways. So the key things to try and remember is don't get bogged down in the movements and things like that. Just remember frontal and sagittal, and they always pair up no matter what. Frontal, if you're putting frontal in, you've got to put sagittal in. So as long as you remember the axis, that will help you out. So if it's F, it's frontal axis, and the plane is a sagittal plane. So the F for the frontal. If it's sideways, S, it's a sagittal axis, and then it's a frontal plane. So we're just flipping them around. Okay. Now when we're talking about twisting movements, the T stands for the transverse, and unfortunately it isn't an axis at that point, it's a plane. But if you remember T for transverse, that's the plane of movement, which is and it is the, imagine if you're cutting the body in half, and it is the vertical axis that comes down here, and unfortunately you've got to just try and remember that. Another way I sort of try and remember it is T for twisting, and we have transverse TV, transverse for the transverse and then the vertical axis. So try to get in the habit of remembering these key things. So T, transverse, TV, vertical. Okay, these are the main movements they are only really ever used, and the most regular question they ask about is cartwheels. That's not to say it will be cartwheels this year, but it is the most commonly asked one. So make sure you really understand the movement patterns in a cartwheel. I hope that has made it clear, and let's move on. Okay, so they may ask you what a lever system is, and particularly an exam question might have the word analyze in it. So it might show you an image, a lever system, or whatever, like this runner down here, or someone doing a bicep curl here. And then the question says, or even this one here, there's someone stepping up or onto a box or jumping. And this exam question says, analyze the lever system. Okay, now you don't have to worry about the classes at that point. It would help, but you don't have to talk about the classes if it says analyze lever system. You need to say what a lever system is, okay? And it's broken down into three parts. We have the fulcrum, the point at which movement is occurring. So in general, and often that's the joint. And in most cases, in the exam board, it's going to be the elbow joint where we have flexion or the ball of the foot. The load, so the weight or the resistance that your body is trying to overcome, and then the effort, the muscle that is working. Okay, so when you're analyzing, you might get this image here, and it says analyze it. So you need to say, right, the fulcrum is at the elbow joint, okay, and the movement is a flexion of the arm because the arm's bending. The load is the weight, the dumbbell that they're trying to move, and then the effort is created by the bicep pulling at the elbow joint to create the flexion. And that's as simple as that. If this example here, they show you the ankle and they say what's happening at the lever system here, well, the fulcrum is the ball of the foot. The load is the body weight as you're running, and then the effort at this point would be the gastrocnemius because that's connected to your foot. Contracting and moving the runner forwards. So don't worry about if it's lever system 1, 2, and 3 if it says analyze. Just remember what a lever system is and how you break it up. And this is taken from a screenshot from one of the examiner reports, and just so it shows you how they've labeled it up. So you could pause the video and just quickly read through that. But remember, analyze, you just got to describe the three parts of the lever and what exactly they are doing and where they are. Now, it always helps to remember the acronym for levers, 1, 2, 3, FLE. I'm sure your class teachers have taught you this before. I know I have taught my class this, 1, 2, 3, FLE. So when we're talking about levers, we need to remember the lever system 1, the F, whatever's on this side is in the middle. So you might have to draw a lever, and it might say draw lever system 1. As long as you remember 1, 2, 3, and I'd write this out at any lever system question, the F, whatever you write in these this side here, the letters, that goes in the middle. So lever system 1 is F in the middle, lever system 2 is load in the middle, L, and lever system 3 is effort in the middle. Now on the other sides, it doesn't matter what you put. You can put it, it just depends on which way it's facing. The key thing to remember is in lever system 1, class 1 levers, the effort is pushing down and so is the load. In all the other times, the effort is pulling up, okay? And load is always going down. So the next confusing thing is about mechanical advantage and disadvantage. Now, if you remember advantage as your main revision part, the disadvantage is just opposite. You don't have to remember both. The advantage is generally asked the most. Disadvantage is occasionally asked. So if you're going to remember anything, remember the advantage, and if disadvantage comes up, just think, well, what is opposite to an advantage? Firstly, the opposite to advantage is a disadvantage. Okay. So in an advantage, and if you get confused by all of these images and the resistance arms and effort arms, just remember this: the effort arm is longer than the resistance arm. Okay. If you can recall that, then you'll be fine. So in this sense, they have a fulcrum, which is where the movement's taking place at or around. The load is in the middle, pushing down, and then the effort is the muscle that's going up. So we've got body weight going down, muscle contracting to lift you up. So we have this point from the fulcrum to the effort, it's called the effort arm, and that is longer than the point from the fulcrum to the resistance, the load arm or the resistance arm. That is meaning the effort arm is longer than the resistance arm. And what it means is that you can lift a heavy load with relatively small effort. So if you think about your body weight, whatever weight that is, you can go up on your tiptoes very easily. And you can lift your body weight on your toes. You could probably do it on 1 foot up on your toes. Okay, so you're lifting a heavy load with relatively small effort. This is lever system 2 in your foot. And this is generally the point where it's occurring in your foot, lever system 2. Opposite side, disadvantage. Resistance arm is longer than the effort arm. So that's the opposite of what you've written down for the advantage. So the resistance arm is now longer than the effort arm. Okay, so it's further away. The load is further away than where the muscle is. And it's the opposite. So large effort is applied to move relatively small loads. So we're just flipping it around. And I said this was the foot, and this is your arms. Okay, so this is lever system 3. So if you think about how easy it is to lift your body weight up on your toes, think about how easy it is or difficult it is to do a pull-up or lifting your body weight using your arms and bending your arms. You struggle a lot more. Many people can't do a pull-up, yet they can lift their body weight on their feet. So try to remember the advantage, and the key thing is these 2 points. Effort arm is longer than resistance arm. You can lift a heavy load with relatively small effort. And then just think opposites for disadvantage. If I was a betting man, I would just learn this one here because this is one that tends to come up, the advantage. Okay, now we get into the classes of levers. Try to remember them as classes than types because there's muscle types and all these sort of things. It's easy to try and remember a lever as a class. So you've written down 1, 2, 3 FLE. So that means in lever system 1, the fulcrum is in the middle because it's 1, 2, 3 F in the middle. Okay, sometimes you'll be asked to draw it. Sometimes you'll be asked to label it. So as long as you've got the fulcrum in the middle, you'll be fine. Now, very rarely is this asked, but usually it is asked and is saying, well, there's an example of one, what lever system is occurring. So they tend to say, this is the example, what lever system is it? And the two they tend to do is heading in football, the neck, and then the only other place that really takes place in lever system 1 is in elbow extension. So usually a throw on. If you go into A-level PE, they start talking about pushing up from headstand to handstand. But generally it's, throwing the ball from from flexion to extension. So the elbow joint is lever system 1 in this scenario. And that's pretty much it for lever system 1. Lever system 2 is probably the most regular question, and so let's start from the beginning. Lever system 1, 2, 3 FL, the load is in the middle, it is generally only found in your foot or your toes. Okay, so the exam question will probably, they show a picture of the trampoliner here, and they say the ankle, the toe, pointing their toes, what lever system is it? Or this one here, going up on your toes to serve, or here, a heel raise. So they give these sort of things, and then they say, what lever system are we talking about? Well, lever system 2 is only to do with your feet, your toes, so think lever system 2 toes. Okay, try to remember that. And they generally ask you to give other examples, so pretty much any situation where you're using your feet. So keep it simple, taking off in a jump, so like a swimming start, or a triple jump or a long jump, the takeoff. Jumping uses your feet. Transferring your weight, it could be a rugby player pushing from one side to the other. But yeah, running, but be specific. So don't say running down the line in football, something like that. Okay, now lever system 2 is also the time we will find our mechanical advantage. So again, this is where the regularity question comes in. So often, like I say, they'll ask you a question on lever system 2, and then they'll say, this is an advantage, why is it an advantage, or what is this? Is it a mechanical advantage or disadvantage? So why is it an advantage? Well, we can lift relatively heavy loads with small amounts of effort because the effort arm is longer than the resistance arm, and that's 2 marks straight away if you can remember that. And we have memorized it because I told you to. The disadvantage is flip side, and we'll talk about that in a minute. So why is that important? Well, the body is a heavy weight. Your body is heavy. Okay, and you can move it with relatively small force in your muscles. If you can use lever system 2, the advantage is that you can get higher in your jump. Okay, simple. Third class lever. Okay, and generally, if you look at all the pictures here, it's kicking a football. That's pretty much the example they use. So let's go 1, 2, 3. F, L, E. E's in the middle. You might have to draw it out. You might have to label it. Just remember, E is in the middle. So usually it's kicking the ball at the knee joint, and that is the most commonly asked example you will face. Effort is in the middle. We've talked about that already. It could be the bicep curl, bending your arm and performing a bicep curl. So there are 2 examples that you need to really know, but generally you're more likely to be asked, is it going to be kicking a football? And because it's opposite to our foot, it is our arm, we are talking about our mechanical disadvantage, the opposite to the advantage. So it's a disadvantage. The resistance arm is this point longer than the effort arm, and you can't lift as heavy loads. So remember, we said the advantage, you can lift heavy loads. Now you can't lift heavy loads, and a lot of effort has to be applied to move that load. And that is all we need to know about our lever systems. Now, just on another chance it could come up, the lever system 1 could be a mechanical advantage, or it could be a mechanical disadvantage, depending the point on the pivot. The fulcrum depends where the fulcrum is placed. So obviously, if the fulcrum is placed more to one side, or say closer to if the fulcrum is closer to the effort, then it's going to have a smaller effort arm, and it'll be a disadvantage. If it's closer to the load, you're going to have a larger effort arm, and therefore it's going to be an advantage. And the points still remain the same. That hasn't come up as an exam question, except for rowing. Once off it came as rowing, and they put the fulcrum as part of the boat. So that's an exam question you want to look out for, but don't panic too much about it. These questions are generally going to be 1 to 2 to 3 marks maximum. So don't lose sleep over these, but that is lever systems and planes and axes in a nutshell, and I really hope this has helped, and good luck for your exams.